So we've established what an exponential function is. Let's do a quick refresher. So in section 6.4, we're going to start by graphing the same function we did in section 6.3, and that would be an exponential function of f of x is equal to 2 to the x. And so we saw in our previous lecture, and again, we don't necessarily need to plot the points, but they're going to help us with the next part of this. So if we plug in -1, we get 1/2. If we plug in 0, we get 1. If we plug in 1, we get 2. And we can graph that. And it should be a very familiar graph at this point in time. So 0, 1, 1, -1, 1/2, and +1, 2. The graph comes in and looks like this. So this is the graph of y equal 2 to the x. We also know the domain and the range. More importantly, it does have an asymptote, and I need that asymptote in there. So we're going to draw that in there. It's right on top of this axis. It's the line y equal to 0. So that's our exponential function. And we noticed that in the previous section that yes, it is 1 to 1. It's an increasing function, but it is 1 to 1. Well, because it is 1 to 1, that means it has an inverse function. So let's go find the inverse function. So to find the inverse of this function, we're going to start off with our y equals 2 to the x. And then we know all we need to do is switch the x and y values. So that would be x equals 2 to the y. So there's the inverse. So at this point, it still looks like an exponential function. Let's go graph it. And to graph it, what we're doing this time is we're going to pick the y values and I'll evaluate for x. So I'm going to use the same numbers, but this time we're going to put them in the y column. So again, I'm taking these set of x values and putting them over here for y. So when I plug in -1, 2 to the -1 is a half. 2 to the 0 power is 1, and 2 to the first power is 2. So we get the same exact numbers, but they now switch places, which we're expecting because it's the inverse function. Let's plot these guys. So at 1/2, we're down at -1. So that would be down here. At 1, we're at 0. And then at 2, we're up at 1. So it's going to look something like this. And again, you can plug in some more values if you wanted more an nicer curve or a prettier picture or whatever. But those three are enough to give us an idea of what's going on. So there is the graph of x equals 2 to the y, which indeed is the inverse of our y equals 2 to the x. Sure enough, as we're expecting, they are reflected across the line y equal to x. That's exactly what we're expecting. What about an asymptote? Do we think it's got an asymptote sitting in there? Well, yeah, it definitely does. If y equals 0 was an asymptote on our original function, then x equals 0 is a vertical asymptote for the inverse of that function. So there it is. So we graphed it without ever really calling it what it is. Okay, so remember this. Like I don't want to erase it completely because I kind of need it sitting there. So I'm going to erase my graph instead. So we're now ready to define something called a logarithmic function. And the reason we do this is because in algebra, we're trained to think of things as y equal to, and this is not a y equal to equation. So we need to rearrange something, do something to make it over to a y equal to. So what we do is we're going to come in and define a function that is the same as x equals 2 to the y, if and only if y equals log base 2 of x. Sorry. Let's do this more as a generic one. So I'm going to take out the 2, call it an a, so that we would have log base a of x. So for our function right here, it would be, yes, indeed, log base 2 of x. So now it's a y equal to function. So now we can work with it as we normally do everything that we've been doing with the functions. So what's important to notice, and in both cases, this is the base. Notice where the exponent went. So here the exponent is sitting up there as an exponent. But in this form, it's sitting over here not as an exponent. It's now on the same line as everything else. The y, the log, and the x are all on the same line in your notebook paper. This is a little subscript written below. So, okay, so this is what we consider to be the exponential form. This is what we consider to be the log form. These two expressions are the exact same expressions. They're just written in different forms. Just like saying hello in 2 different languages still means hello. It's just said 2 different ways. So this still means the same thing, the same relationship between x's and y's. They're just written in two different formats. So where we always start with this, oh, let's come in and talk about base. So again, that base has to be greater than 0, and it can't be equal to 1. And both of these comments should make sense based on our previous work. If I make this base a negative number, so something like y equals log -3 of x, then that means that I can take -3, raise it to the y power, and get a value out of it. So how can I take a negative number, raise it to the y power, and end up with a positive x? I can't. So that's why the base has to be positive. And we saw also in our previous work that when we let it equal 1, it's a constant function. And we don't want that. So where we always start with logarithms is just switching between the two forms, just to get you used to translating between those two forms of the exact same equation. So I like to do what I call as the lassoing theory. So I always start with the base, the first thing I circle or pick up and write, and then I go around the equal sign. So in this case, I would start with the base, and then I go around the equal sign. Make sure I draw it right. So what you're going to see on your handout is a table. And the table simply has us convert back and forth between these two forms. So the first column is the exponential form. The second column is the log form. So in the exponential form, we see 3 squared is equal to 9. So the first thing I'm going to do is write the word log, because that's the form they're having it to go to. I'm going to pick up the base, because it's always the first thing I use when I go to rewrite things. And then we're going to go across the equal sign. So now we're going to pick up that 9 and set it equal to 2. So 3 squared equals 9, which is a true statement, is the exact same thing as log base 3 of 9 is equal to 2. Okay, our next example is 10 to the 4th is equal to 10,000, which we know is true. So again, I'm writing the word log because I'm going to the log form. I need to insert the word log. We'll pick up the base of 10. We'll go across the equal sign to pick up the 10,000. And we'll set it equal to the exponent, which is 4. So 10 to the 4th equal to 10,000 is the same expression or equation as log base 10 of 10,000, which is equal to 4. We have 4 to the -2 is equal to 1 over 16. So again, we're going to log form, so we'll pick up the word log. The base here is a 4. We go across the equal sign to pick up the next part of that expression, and that's going to be equal to -2. And there it is. Okay, so that's going from exponential form to logarithmic form. Well, now let's go the other direction. So now we're going to start with the logarithm and rewrite it as an exponent. Okay. So we have log base 5 of 125, and that's going to be equal to 3. Okay, so this time we're taking it out of the logarithm, so I'm not going to write the word log. I am going to start with that base. So the base is a 5. I'm going to go to the 3 to pick up the next number and set that equal to the 125. There it is. So 5 cubed is 125, which we know is true. That should make some sense. And we have log base 2 of 32 is equal to 5. So again, we'll start with the base, which is 2. We're going to go around the equal sign and pick up the 5 and set that equal to the inside, which is 32. We know that 2 to the 5th is equal to 32. And then finally, log base 7 of 1 is equal to 0. So the base is the 7. We're going to pick up the 0 because we went around the equal sign and set it equal to 1. So and again, in each case, I'm doing this. So I start with the base and go towards the equal sign. And there they are. So we've now gone between the two different forms of the expression.